Welcome! This tutorial is brought to you by the Research Experiences and Microbiomes Network, or REMNet, and the City University of New York. In this video, you will learn how to isolate and analyze a subset of your project's OTUs, or Operational Taxonomic Units, at a specific taxonomic level using the text-to-columns, remove duplicates, and sort tools, and the SUMIF and COUNTIF functions in Microsoft Excel. To do this, you will also learn how to convert your relative abundance values into their number of sequences. In order to follow along with us today, you have received taxa summary files and a data summary document of your analyzed microbiome samples, and you have opened them in Excel. If you need a refresher, please review our tutorials called Accessing Your Microbiome Data, Understanding Your Microbiome Data Summary Document, and Organizing Your Microbiome Data. As you work with us today, you are welcome to use keystrokes or your mouse to utilize these commands and functions or to select necessary cells. To orient you to this table, column A contains the hierarchy of taxonomy for each of your OTUs. And columns B through E report the relative abundance of each OTU within each sample. Before we get started, we will save our tab-delimited TXT file as an Excel XLSX file. Many of the tools and functions are not compatible with the tab-delimited file type. To do this, we will go to File, Save As. We will choose the Excel Workbook XLSX from the pull-down menu, and we'll click Save. In this example, we will isolate the OTUs at the order taxonomic level. We will use the text-to-columns tool to separate the taxonomic levels in column A. You will need 5 empty columns to your right to complete this next task. So to create those 5 empty columns, you have a few ways you can do this. You can select your data. When your cursor makes a hand, you can slide your data. Or you can select empty columns and go to Insert Sheet Columns, or you can go to Insert Columns. Now, select column A with your taxonomy. You'll go to Data and click the Text to Columns tool. Make sure you've selected Delimited, click Next, and our taxonomy is separated by semicolons, so click semicolon. You see an example of your output, and we'll click Finish. And now your taxonomy has been separated, and we will create new headers to reflect this change. Before we can proceed with any functions or formulas, we must convert the relative abundance values to the number of sequences for each OTU. Insert a row below your header so we can paste in this information. And you can insert this row a number of ways. Just like you inserted the columns, we can right-click, go to Insert, and we're going to identify that this is our relative abundance data. We'll just give our columns a little note, RA for relative abundance. Next, go to the Final Seeks Stats tab in your data summary document for your data set. Relative abundance for this data set was calculated after unidentified sequences, incomplete sequences, or bad reads and eukaryotic contamination or non-target sequences were filtered out. In the final column, you will find the final number of sequences remaining for each sample after these filtering steps. We're going to copy those sequence values for your 4 samples. You can right-click and copy or go to Edit and Copy. We'll go back to our data table. And you can right-click, and this time we want to select Paste Special, and we want to transpose, and click OK. And our sequence values have pasted in our empty row. Relative abundances for the OTUs in each sample are a proportion of this total number of filtered sequences. We simply need to multiply these two values. So we'll make new header columns. And instead, we'll go to Edit and Find and Replace. And instead of our relative abundance note, we will replace with the number of sequences. And we'll replace all 4 of those. Yes, we want 4 replacements. OK. And we will close. We can create a multiplication formula by typing the equal sign in our new cell, K3, and we will select our first relative abundance value from that same row. We'll type in the asterisk, and now we will select the number of sequences. Now we need to modify our formula to hold the number of sequences constant for every one of the OTUs in our list. To do this, we'll use our mouse cursor to select between G and 2 and type a $sign and hit Enter. Now we want to fill this formula to the rest of the row. You can do this by 3 ways. In that bottom corner where you see a small box, when the crosshairs turn black, you can grab and pull down. You can select a number of cells and go to Edit, Fill, and down. Or when your crosshairs turn black over that bottom corner, you can double-click, and it'll automatically populate that column. Now let's just click on a couple of these to make sure that each row is multiplying the relative abundance by the number of sequences in G2. And that is indeed the case. So we can use one of those same options to fill out these columns. And I'm going to use my favorite method of selecting my top row and double-clicking. To double-check our formula, we can calculate the sum of all of the OTUs. If our formula is applied correctly, the sum of the new column will equal the correct number of sequences originally obtained for that sample. All formulas can be accessed by typing the equal sign in a cell, and you can type in the sum function or select it from a list. And in the open parentheses, you need to select all of the samples in that column. You can drag your mouse, or I'm scrolling all the way to the bottom. I'll hold the Shift and select. And hit enter to complete. And you'll need to apply this to all of your samples. And for some formatting and housekeeping, let's view this as whole integers. This is just this data is meant to be displayed as whole sequences. We'll go to Format, Cells, Number, 0 decimal places. OK. And we see that the sum does indeed match the filtered number of sequences for each of our samples. We have done this correctly. Next, we want to isolate our orders and remove any duplicates. So we're going to copy this column. We're going to paste. Under Data, we'll select Remove Duplicates. You'll get a report in the Remove Duplicates box of how many will be removed and how many will remain. Click the Remove Duplicates button. And sort your remaining orders alphabetically. Make sure that your column is selected. Under the Data tab, we'll click Sort. We want to continue only with this column. We do have a header, and we want to sort from A to Z. We will now demonstrate how to use the SUMIF function to quantify the number of OTU sequences for each order. The SUMIF function selectively sums a specific subset of values from a larger list. So we'll move over here. And make a new SUMIF column. And again, hit the equal sign, and you can type in your formula, or you can select your function from a list. And in the open parentheses, we're requested to select the range, the criteria, and the sum range. So first, we will select our range, which is the original unmodified column of orders, and we'll type a comma. Our criteria is going to be the specific OTU for that row. We'll click that cell and type a comma. And the sum range will be the sequences from our project. So we want to select those 4 new columns we made, K through N. And just to review, this is what your formula should look like. And hit enter. And use your favorite method to apply this formula to the rest of the column. We will now demonstrate how to use the COUNTIF function to count how many OTUs from your samples are in each order. This will allow you to see which orders are most abundant in your data set. We'll add a new COUNTIF header. We'll hit the equal sign, and we can start typing in our function or select it from a menu. In the open parentheses, we'll select our unmodified list of orders. We'll type a comma, and we'll select the specific order as our criteria. And we'll hit enter. And again, use your favorite method to fill that formula down, the entire column. So to summarize today, you learned how to use the text to columns, remove duplicates, and sort tools. You converted your relative abundance values to their number of sequences. You also learned the SUMIF and COUNTIF functions and formulas, and you learned how to apply these functions to all of the cells in a column. Thank you for participating. If you found this helpful, we invite you to view our other tutorials guiding you through your microbiome dataset.